In this video, we're going to talk about the closed interval method. The closed interval method is really useful for finding the absolute maximum and absolute minimum on some sort of a closed interval. It's really simple. It goes like this. So, the closed interval method is applicable to continuous functions. So we assume that f is continuous on the closed interval from a to b. To find the absolute maximum and minimum, you need to do 3 steps. Step 1 is find the critical points or critical numbers in the open interval from a to b. Step 2 is plug the critical numbers and the endpoints into the function f. Then the third step is simply to pick the largest and smallest numbers. So the largest obviously will be the absolute maximum, and the smallest will be the absolute minimum, from step 2. It's as easy as that. So we'll do a quick example. So here's our example. It's going to be the function f of x equals 2x cubed minus 3x squared minus 12x plus 1. And our interval is going to be from -2 to 3. So first thing we need are going to be our critical points. So we're going to take the derivative. F prime of x is 6x squared minus 6x minus 12. We're going to factor that, so we can pull an 6 out of each of the terms. So we're left with 6 times x squared minus x minus 2. And we can factor x squared minus x minus 2 as x minus 2 multiplied by x plus 1. So we can find our critical numbers by setting this equal to 0. This function is 0 if and only if x is equal to 2 or x is equal to minus 1. Since both of those numbers are inside our region, all we need to do is plug -2, -1, 2, and 3 into our function, pick the big ones and the small ones. So let's start here. F of -2 is 2 times -2 cubed minus 3 times -2 squared minus 12 times -2 plus 1. Okay, get a little space here. So that's so the first term is 2 times -8 gives me -16. This is -3 times +4, which is -12. And then the next term is -12 times -2 gives me 24 plus 1. So now, let's see. Negative 12 plus 24 is it's positive 12, excuse me. So it's negative 16 plus 12 plus 1 gives me negative 4 plus 1 is negative 3. There's 1. F of, let's see, the next one is, let's do negative 1. So that's going to be 2 times negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1 plus 1. Get a little space here. So we have negative 1 cubed is negative 1. So that's negative 2. Negative 1 squared is positive 1 times negative 3 is negative 3. Negative 12 times negative 1 is positive 12 plus 1. So we have, let's see, negative 3 plus 12 is positive 9, minus 2 is positive 7, plus 1 is 8. Okay, that's 2 of our 4 points. Going back up here. We still need to check numbers 2 and 3. So plug those into our function. Right, so f of 2 is 2 times positive 2 cubed minus 3 times positive 2 squared minus 12 times positive 2 plus 1. That gives us 2 times 8 is 16. 3 times 4 is 12. 12 times 2 is 24 plus 1. So 16 minus 12 is 4. Minus 24 will give me negative 20 plus 1 is negative 19. And finally, f of 3 is 2 times 3 cubed minus 3 multiplied by 3 squared minus 12 multiplied by 3 plus 1. So let's see here. I'm going to think about this first term as 2 times 27 because this next term is 27. That'll save me a little bit of effort. Minus 36 plus 1. So if I have 2 27s, I take one of them away. I have 1 27. I've got 27 minus 36 plus 1. Okay, 36 is 9 larger than 27. So that's going to give me negative 9 plus 1. That's negative 8. So going back over the 4 values that we have, we can see which one is our big one. So the biggest one that we have is going to be this negative 8 here, or sorry, positive 8. And our smallest value is negative 19. Right? So let's just record all of those things so we can see them all at once. So when x is negative 2, my function value f of negative 2 is negative 3. When x is minus 1, let's go back up here, my function value is positive 8. So that's an 8 there. We have when x is 2, f is negative 19. And finally, when x is 3, f of negative 3 is negative 8. So we can see that our maximum value on the interval occurs here. So this is going to be our maximum. And our minimum value is going to occur here at 2 negative 19. And there we go. So this is our absolute maximum. And this is our absolute minimum. And that's it.